Hello again, everyone. Thanks for joining us. My name is Rob Morris. I'm here today with Aish Vardani, and we're going to talk about new resources for the classroom that we've been developing here at Wolfram. These will primarily focus around the programming lab. So you may have seen me or gotten emails from me. I'm the product manager for the Wolfram Programming Lab. So we're going to talk a lot about that today. But before we do that, I want to also talk about why we want to use the Wolfram language in the classroom to begin with. Okay, so like I said, you are probably here because you are familiar with the Wolfram language. Maybe you've used Programming Lab before. How many of you have used Programming Lab? Raise your hand. Let's say that's inconclusive. So I'm just going to assume that you guys have some familiarity with the Wolfram language. You're interested in getting the Wolfram language into your classroom. But why do you want your students to learn the Wolfram language? There are a ton of languages out there you could be learning. There's a lot of competition in that space. So why would you want to use the Programming Lab, and why would you want to start with the Wolfram language? Well, it has a lot of advantages over other languages as a sort of first language. We think it's a great language for people to pick up first. Not only that, it has a long history of being very useful and being used by top industries and top research and so on. It's been around for almost 3 decades, and it has contributed to Nobel Prizes. It's put flights into space and all sorts of things. So it's very useful, and at the same time we think it's very easy to learn. So first off, what kind of language is it? How would you describe it? Well, the Wolfram language is primarily a symbolic language and a functional language. Symbolic means that it doesn't just have numbers and stuff in it. So if you asked Wolfram language what the area of the unit circle is, it would tell you pi. It wouldn't tell you 3.1415 and so on and so on. It would tell you pi. It recognizes that as a symbolic thing that it can compute with. That's a very different type of computer interface that from what most languages have. That allows you to do interesting things. Being a functional programming language means that it's not driven as much by the procedural tropes that you use in things like C and Java. You don't use as many for loops and do loops and nested while conditions and all those things you might think of as older computer languages. Functional programming is become more and more popular because it automates a lot of the programming for you, and it's easier to understand from a human perspective. It's better, what do I want to say? It's more like how humans think and less like how computers think. So functional programming has gained a lot of traction in the last few years, and we were one of the first major functional programming languages. So you're probably familiar with things like Mathematica, the Programming Lab. You may have heard of the Wolfram Development Platform. These are all places where the Wolfram language is used. The Wolfram language is it's its own standalone language. You can compile it and create programs in it and send those off to people. But these are the places where you would go to do work in it. So if you are confused, is the Wolfram language Mathematica? Is the Programming Lab the same thing as Mathematica? They all use the Wolfram language, and if you learn the Wolfram language in Programming Lab, you can take that to other products and do other things. So development platform is where you would go after you learn the Wolfram language and you want to create a website that does something. So each of these have their own advantages. I'm just going to really talk about the Programming Lab today. If you want to learn about these other ones, though, I recommend going to our wolfram.com site. There's a link here that has great information on all the things that use the Wolfram language. So how is it different from other languages that you may have heard of? You could be coming from any direction here. You could be familiar with Scratch, you could be familiar with Java and C++, Ruby, HTML, all these languages that are out there now. What makes the Wolfram language special? If we have time at the end, I'd like to go on and do some hands-on coding and show you, what really makes the Wolfram language special. But that's sort of tangential to what we want to talk about, so we'll see how much time we have and if there's interest in that. But to give you a high-level answer, it's very automated. You don't worry about very low-level algorithms. If I want to make a 3D plot of something, I don't have to call in 3D graphics libraries. I don't have to do all these weird algorithms or anything. I just say plot 3D, and it just does it. The language figures out what to do, it understands what you want to do, and it does it for you. So that's a big advantage over other languages. Another one is that the function names are very easy to read English words. So if you've tried other languages, they look like like somebody took a book and just cut out half of the letters. They have no idea what any of the functions mean. But in the Wolfram language, like I said, if I want to do a three-dimensional plot, it's plot 3D. If I want to do an integral, I use integrate, stuff like that. So it's easy to read, easy to recognize, makes it much easier to debug too. There are a lot of things that you don't have to do in the Wolfram language that you have to do in a lot of other languages. You don't have to declare what a function is. I don't have to say if this is going to be a real, if it's going to be an integer, things like that. You don't worry about it. The language figures it out. It knows what to do. It's smarter than those dumb old languages. You don't have to allocate memory for anything. I don't have to worry about where the pointer to this memory address is. All that stuff that's in the past. Computers are beyond that now. And you certainly don't have to worry about compiling the code. It self-compiles. All you have to do is run it. Oftentimes it doesn't look like the Wolfram language code is code because it's so compact. It doesn't have that same stink of C where you have a whole int main, declare this, all those things. All that's gone. You don't have to worry about that. It's very clean. It's very easy to approach. We think that makes it a great first language. So if you're familiar with Mathematica, you're probably familiar with it in a scientific setting, or you may have heard about it in an engineering course or something like that. And it's true that the Wolfram language was first developed within Mathematica, and it has a long storied history in the sciences, in math, research, and so on. But it's a lot more than that, and now especially we've built in tons of curated data sets. We can visualize data like no other language. We built in dynamic interactivity. That's a big thing that separates us. So if you want to create something that's dynamic and interactive, it's literally trivial to do in the Wolfram language, and no other language can do that. So these are the good reasons why it's a great first language. It's not just something you do, your homework in. It doesn't just help you with calculus. You can do full-on coding projects. You can see some of these in action at the demonstrations project. So demonstrations.wolfram.com. There are thousands and thousands of things people have built. And so you can see what you can do there. You can point students to it. They can get ideas. They can see the code. They can learn how to do these things themselves. One large coding project that was done all in the Wolfram language we're quite proud of is Wolfram Alpha. If you're familiar with it, if you've ever used it, the whole thing is done in the Wolfram language. We employ hundreds of people that code in the Wolfram language every day. So it is a real-world professional language. And if your students learn it, they're learning a real-world professional language. So any of the capabilities of the Wolfram language that you want to learn, we have tons and tons of videos available, lots of events we've done in the past, so check out our training site and you can see all those there. Okay, so I've given you the spiel on why you want to learn the Wolfram language. Well, how are you going to learn the Wolfram language? That's where the Programming Lab comes in. Programming Lab is, we believe it's the best place to start learning in the Wolfram language. We are trying to do multiple learning styles to engage people who aren't particularly interested in learning coding one way or another. Computer science has not seen a large adoption broadly through students, so we're trying to broaden the way in which we teach it, and that will hopefully garner more interest among students. So the two main ways that you use the Programming Lab are explorations and a book that's built into the Programming Lab called Elementary Introduction to the Wolfram Language. So I'm going to go ahead and show you some of the features of the Programming Lab. So if you were to just, say, use a search engine and just type in Wolfram Programming Lab, or you come to our main site, you'll probably end up on this page. This is our product page for Wolfram Programming Lab, and it'll give you a nice overview, tell you about what it does. From here you can get some answers to your common questions, you can get resources if you're an educator, and you can look into pricing and the different plans and so on. But what you want to do with the Programming Lab is go ahead and get started using it. So to do that, you click on the big orange button, Start Programming Now. And you notice it says no sign-in required. So it's taking me to a thing called the Open Cloud. The Open Cloud, as advertised, does not require a sign-in. There's no account. It's totally free. Anyone, anywhere in the world that has a web browser can go in and go to this website and have access to the Wolfram language. When you get there, the first thing you want to do is probably watch the video. It's very informative. It gets your feet wet, gets you started. After you've done that, you want to go in and try it yourself. So this will open up the Getting Started tutorial exploration. So like I said, the Programming Lab is built on explorations and elementary introduction. The explorations are over here on the sidebar. They're like mini coding exercises or mini projects that you go through. They vary in difficulty. Some of these, like the Get Started one or these starter explorations, are very simple, just a few steps. But they all follow a similar format. They all have steps like this, and so they'll always have some code laid out. So 2 plus 2. I just run the code, and it gives me a result. That's not a very interesting step, so let's go on to the next one. Range 10, you'll notice, again, the code is laid out. That's the idea behind the explorations, is that the code is there for you, and you don't have to worry about getting the syntax right. Did I get the brackets right? Did I spell it correct? All those things. You don't have to worry about getting the code onto the page. It's there for you. What we do, though, is we highlight places that you might want to change. So you can see here, range 10 is highlighted. Maybe I want that to be range 100. And I can see that as I change that, the result changes, and from that I instantly know what range does. This is how the explorations teach your students to code. It puts the code in front of them, asks them to modify it judiciously and thoughtfully, and from that they will understand how the code works. We don't highlight, the N and G because we don't want to change that, because that breaks it. Instead, we highlight the parts that they should be changing. Most steps, if they're even remotely complicated, will have a Show Hide Details section. This will lay out more information for your students. If you're trying to understand, if they introduce a new function like range, it will explain it a little more, give it a little more context. Most of the steps in the explorations have Show Hide Details involved with them. Then, if you make it through, you can challenge yourself with what's called the Go Further section. The Go Further section, you'll see you have to sign in for that. So the free version, well, the open cloud version has all these explorations, and you get to use the exploration itself. If I create a free account and then I sign in, I'll get access to the Go Further notebooks, and I'll also get access to more explorations over here. So I have an advanced section of explorations now. But these are predicated on the exploration. They ask you to take something that you learned in the exploration and then modify it a little to create something new. And this is where you challenge your students to put the code down themselves, make sure they understood what they were learning within the exploration. So if we have more time at the end, I can go through more of the programming lab. Aish is going to talk a lot about the explorations and what we're doing with them now, what we're trying to introduce in the coming school year. I also want to talk about elementary introduction to the Wolfram language. So the explorations are great if you're trying to do a small project, if you have a sort of small goal in mind. You can also work through Stephen Wolfram's elementary introduction to the Wolfram language if you want a sort of full course on the Wolfram language. It starts literally from 2+2. The whole book is built in. It works you all the way from 2+2 up to very advanced, newfangled topics. There are 40 some odd sections, and if you work through all of the book, you will very much be an accomplished Wolfram programmer. So this is the other leg of the programming lab that I wanted to show off. I'll talk more about this one in a bit, but for now I'm going to hand it over to Aish, and she's going to tell you about the new materials we have regarding the explorations.
Okay, hello everybody. This is Aish Vardhani from Wolfram, and I'm very excited to be here to talk to you about the teacher editions of the programming lab. So just getting started on sharing my screen here. Okay, so you heard Rob talk about what are the teacher editions, what is the concept behind the programming lab and the explorations in the programming lab. As you saw, they are self-contained. They work very well on their own. You have a template where the steps are laid out. They have show high details for remotely complicated steps and so on. What we hope to accomplish with the teacher editions here is giving teachers a template so that they can present the material in the programming lab in a classroom. For example, if you had a lesson plan for an exploration in the programming lab that gave you a goal or a procedure, a reference for each step in the programming lab. Okay, so you're doing the get started exploration, and here is a step, like Rob showed, a step that asks you to get a range of numbers from 1 to 10. If you were accessing this using the teacher edition of this exploration, as an educator, you're going to get a goal for every step. What's the procedure in which we're hoping to accomplish? What the code is trying to do in that step? Possible questions that you can ask your students. For example, what would the output of the range function be if you plugged in a negative number there? This is something that you can put out to your students and, generate a discussion with them. You might get multiple different answers. You can have them try it out. The real answer is also provided to you. The range is going to be empty if you plug in a negative number there. We've led multiple workshops and outreach initiatives using programming lab explorations as well as Dr. Wolfram's elementary introduction to the Wolfram language in multiple local middle schools and elementary schools here. And what we found is that every time we present some of these explorations, there are some questions that come up again and again. Some places where a lot of students perform common errors that we've noticed, or tips that they're going to forget the parentheses over here, or they're going to try typing in a word without enclosing it in quotation marks, and so your program's not going to understand what's going on. So with our extensive experience with our outreach initiatives, we've made a list of common errors and pitfalls that we've noticed students committing, and we've tried to include that in the teacher's editions to help future educators as they use our material. So for some of the sections, for some of the steps in the teacher editions where we know this is going to happen, we also have this section called possible issues. One of the most common things you'll find is that function names need to be capitalized, and this is something that elementary and middle school students, they're going to slip up a couple of times before they remember to do this. And finally, in every teacher edition step, you're going to see a link that takes you to documentation on what this function completely is. So we have extensive documentation. I'm going to show you that here just in a second. With your documentation here, it's going to take you to a web page. I'll get back to this towards the end of my talk. That is going to give you complete details about the Wolfram language function that was used in that particular step. Let's go down and let me show you one more of these before I move on to the next thing that I want to talk about. One of our very interesting programming lab explorations here is called Palindromes of English. And what this exploration accomplishes is a template that allows you to find all the words in English that are palindromes. Now, you can already see how this might be interesting to a elementary, middle school, or even a high school student to be able to write a piece of code that can analyze all the words in your language to be able to pick it out on your own. So we start very simply. We start with one Wolfram language function called string reverse, and it takes an input and it reverses it. So when you run that, you already know what's happening here. We have teacher notes for this. So what is the goal of this step? How do you go about doing it? So we start at the very beginning. As you can see with the teacher editions and even with the programming lab explorations, we start from a very basic starting point. We're not assuming any prior knowledge of programming, not even assuming any special knowledge of mathematics beyond the most elementary knowledge. So we explain what does a string mean, how does a computer understand what a string is, what is the Wolfram language function that we use in order to reverse a string, and what is the input, what's the output, and so on. And then you go on with the step, you reverse rhinoceros, and of course it's not a palindrome. What I really want to talk about is step 3. In step 3, we are trying to select the words that have length 10. The way that we do this, I'm going to collapse the teacher notes just for a quick second here. So you see the snippet of code here that's already laid out that says select dictionary lookup string length, and there's a pound sign, there's a double equal to sign, there's a 10 and an and. Now, like Rob mentioned, one of the very striking features of the Wolfram language is that it is very easy to read, and this is something that strikes a big chord with students who are learning a programming language for the first time, that what they read is approachable to them. They're able to understand it just by looking at the snippet of code that you're trying to select something, perhaps from a dictionary, and what are you looking for? You seem to be looking for the criterion string length, and you're looking for something that this is equal to a 10. Perhaps the only thing, if you've gone through a couple of these explorations before, that's going to puzzle you a little bit is, what is this pound sign? What's this ampersand over here? And so on. So that's the kind of stuff that we spend a lot of time describing in great detail in the teacher notes about, you know, the equal operator is how you assign equality. It's not, you know, x equals y, it's x equal y, and so on. About stuff like what is a pure function, and, you know, how do you select these words using the hash sign. So we're hoping with the teacher editions that steps like these, for a educator who spends time going over the notes that we provided in the teacher editions, this material becomes even more accessible to them, even if they do not have prior programming experience. One more thing that I'd like to point out regarding the way in which we've added material to the teacher editions. Like I said, we've had extensive outreach experience that helps us to add interesting points and tips that we think the teachers will find useful one of the things that I always find in the workshops that I run, even in a middle school setting, is a lot of Wolfram language code ends up having arrow marks that allow you to give options to your functions. For example, let me show you here. If you're trying to draw a sphere, and if you are trying to draw one, okay, so this code here, graphics disk, image size, arrow mark 100. This draws a disk with an image size of 100, and of course you're going to be able to change that, make it a little bigger, make it smaller, and so on. But when you have a student try to type this code out by themselves or modify it in some way, one of the most common questions I faced is, how do I draw the arrow mark? And as a programmer or as a professional, this is not something that might seem obvious from a developer's point of view as to, oh, I actually need to teach somebody how to do this. But we found with our experience in outreach that these are the kind of points we should be hitting with making our material accessible to teachers and students everywhere, that this is how you draw an arrow mark. You just type the dash key over here and then the greater than, and then they just fuse to give you this arrow mark. And I've seen students get so excited and happy when they're able to do that on their own. And we've tried to inject that sort of a mentality into all our teacher edition notes, trying to be careful about what to put in there and how this is going to, improve the quality of instruction when somebody is using the Programming Lab material. The next thing I want to talk about is Programming Lab modules. So modules are Programming Lab planning guides. They are tailor-made to fit a specific duration. So say you're an educator and you want to present Programming Lab material in your classroom, and you could do this in multiple different ways as I'm showing here. Maybe you want to do a short introduction just for a 3-day intro into Wolfram Language programming using specific explorations. So we've created a tailor-made guide that will suggest based on if you are in elementary school or middle or high school, you want to do a 3-day module, okay, here are the ones that we suggest that you pick that are going to give you a broad overview of what is possible in the language, a smattering of activities that are both fun and informative to the particular age, the grade that you're teaching in. We have modules that are a little bit longer, like a 5-day series or even a 10-day to a semester-long engagement with this material. To continue on with my outreach experiences, I have used the Programming Lab explorations in local middle schools here that lasted 2 semesters long, and there is enough material there to comfortably cover such a long duration, as well as remain interesting and relevant to the curriculum that the students are learning. So we've tried to make that a little easier for teachers to say, okay, here's this tool, here's the Programming Lab, and then if you want to, just dip your toes in, here's a 3-day introduction module for you, depending on you're an elementary or a middle school teacher. You want to go a little bit longer, we have modules for that, and this will be part of the preview material that Rob is going to be talking about in a little bit over here. So we suggest explorations based on what we found works best with different age groups. We've also found that the longer ones are more successful because they give the students a chance to really dive into the material, both from the standpoint of the Programming Lab and the elementary introduction to the Wolfram Language book. The last thing I want to be talking about is something that we're super excited about, which is Programming Lab themes. We see the Programming Lab as a wonderful tool to not just be used in a computer science setting or in a computer science class, but as something that can be used across different subject areas, across different curriculum. So we see this as a tool to complement existing curriculum in different subject areas. And I know that as far as the Wolfram Education team is concerned, we've been talking about this for a long time as to how our offerings are not restricted into this narrow, this is just a programming language sort of space, but as a way to inject a computational thinking mindset and a programming mentality into you name the subject, we can probably inject Wolfram Language programming into it. That has always been our mindset about this, and it's in that idea that the Programming Lab themes follow. So here we hope to provide modules which are very similar to the ones I talked about earlier, but these are now segregated by, here's a module on Wolfram Language material that are related to image processing, or astronomy, or other areas in physics, or even text analysis in English class, or geography, and of course, mathematics. This is a wonderful way for your students to get access to a rich source of material for the classroom that transcends subject areas. And it's possible to implement all the material here that we're presenting in multiple different ways in your classroom. You can get as engaged with the material as you are able to, whether it's something for a very short duration or something that's much longer than that. We feel that we have the material and the resources to help support that. And with the release of these special materials, we're hoping that teachers and educators find it easier to bring programming into the classroom while they're adding to this, building a computational thinking mindset in their students in multiple areas, while also adding a programming language to their toolkit. So we see that as a win-win. There are two wonderful active groups on Wolfram Community. If you've not already checked it out, I urge you to check out community.wolfram.com. It is an online meeting space for all Wolfram users. A lot of them work with us, and we have loyal users from all over the world who visit here, who post interesting stuff. There are two particular groups that might be of interest to you. The WPL group, the Programming Lab group, and the education group, where educators and teachers are always talking to each other, exchanging ideas, and discussing interesting use cases of the technology or helping each other out. So I hope that you visit that, and I'm going to pass it back to Rob, who's going to be talking some more about the book.
Thanks, Aish. Before I get to that, I sort of jumped the gun. I got really excited for you to see the new teacher editions that I totally forgot to tell you about the preview program. So all of the things that we're showing off here are going to be available for preview over the summer going into the next school year. Everyone that is here today will be eligible for the program. We'll follow up with you in a week or two by email. And if you're interested, just email us back and we'll sign you up for the program. If you have any colleagues or friends that aren't here but you think they would be interested, just have them email me at rob_morris@wolfram.com. and I'll get them signed up as well. We will be communicating regularly throughout the summer, probably once a month, and updating you with new things that we've created, some more modules, more teacher editions, things like that, and we will be giving you advice on how to incorporate these things into your classroom. And of course, we are very interested in hearing your feedback from these. We want to know, do they work? Are there changes we want to make? Someone already commented that the contrast isn't the best. So those are great kinds of tips that we want to hear just to make these as successful as we can. Okay, so you've seen the teacher editions, and next I want to talk about using the book Elementary Introduction to the Wolfram Language in the classroom. And I also want to show you some cool new things that we just came out with for the book. So let's get this up here. Oh no, I lost it. Let me find my web browser. Okay, here we go. So I've got Elementary Introduction up here. Now, the book is, like I said, 40 some odd sections, and you can start at the very beginning with 2 plus 2. If you are trying to use this in the classroom, so it's good, students can work through it themselves. They can use it supplementally if they're trying to do a coding project and there's something they need to brush up on. I also recommend, if you're going to be using explorations in your classroom, read through it yourself. It gives you a better background on how to use the Wolfram language. You'll be better prepared for questions and so on. If you are using it, the first 15 sections are really the core basic Wolfram language programming experience. From there, we start to introduce all kinds of topics. Some of them are more specialized, some of them are more advanced, but the first 15 I would work through contiguously. The other ones I would look around and see what's interesting. Machine learning is a big thing now, so we have a lot of automated built-in machine learning. People are talking about AI and big data, and all these things are all the rage now, and so we've got that built in, and it's not hard coding to do. You just have to know the functions. It's all automated. Things like that. More natural language stuff, like we've shown you in the programming lab, of using natural language queries like picture of a horse or something like that, how to incorporate those into your data. Lots of really interesting things, but nothing that is really core to programming in the Wolfram language. So work through these first 15 sections and you will be all set. So as you're working through them, let's go back to this first one. There's always the section text. It's always got some examples that they're laid out for you, and those are nice. Some Q&A and everything. But if you're going to learn something, you have to just get in there and try it. So all of the sections have exercise notebooks available, and these are something we've been working a lot on. So when I click on the open exercises, it's going to open up the exercise notebook here on the left, and I can keep my text open up here on the right. So as I work through these exercises, so compute 1 plus 2 plus 3, I have a few options. I can see what the expected output is supposed to be. Okay, 6, that makes sense. I can try it myself. Okay, let's see if I get 6. Yeah, okay, that worked. Now, this one's pretty trivial, but how do I know that my code was right? Maybe I got the same output, but my code wasn't right. So I can now check my solution, and it's going to go through all kinds of fancy code transformations and all these things that we've been putting a lot of work into, and it's going to look at my code and say, yes, you computed 1 plus 2 plus 3. And it's not the same thing as if I were to, say, do 7 minus 1. Now, before I try to check this, I'm going to give out the obligatory caveat that these are all in development. These are all previews, and they're a little experimental. I'm not exactly sure what's going to happen when I do this, so I got all kinds of fingers crossed. Bear with me if it doesn't. So I know that it evaluates to 6. Is it correct, though? Oh no, it's correct. It shouldn't be. So I need to call somebody about that. But let's talk about other ones. So add whole numbers from 1 to 5. So I can pretty easily add those. See if that is correct code. If I let's say I do 10 plus 13, and I check that. Hopefully that fails. Okay, that's definitely wrong. Okay, good. So it knows that's wrong. These are all trivial examples, though. Let's talk about a more interesting example. I'm going to go to, let's do section 4. So displaying lists. Lists are integral to doing anything in coding. You're always messing with lists and arrays and so on. So you want to visualize them. You want to create them. All kinds of things. You're going to do any sort of basic data analysis. You need to know how to use lists. So this is a great section to get your feet wet. Let's check out the exercises. Like I said, part of the being experimental part is they're loading a little slowly. All that will change. It'll get better. So I like this example here. Make a bar chart of 1, 1, 2, 3, 5. Well, the great thing about Wolfram Language, even if I don't know the function name, I can guess. It's all easily readable English words. So I'm going to guess that the function to make a bar chart is called bar chart. Oh, and there it is. Okay. Bar chart. Great. So let me see if I can just make a list of these guys. Okay, so that's that. Is that the expected output? Yep, that is. It's looking good. Let's see if my solution is correct. Okay, as expected. But let's get a little crazy here. So if you notice the numbers here, 1, 1, 2, 3, 5, those are the first 5 numbers in the Fibonacci series. Being a good mathematically minded language, it knows about Fibonacci numbers. Maybe I don't know the syntax though. So I'm going to click on this little I next to Fibonacci, and it's going to bring up the help function page, or the help page for the function Fibonacci. And I notice that it takes 1 argument, and that gives me the nth Fibonacci number. So that's great. I'm done with you. Now, Fibonacci. You don't even know how to, I have to know how to spell it. It'll spell it for you. So let's say that I wanted the first Fibonacci number. Okay, that's great. Now I want a list that's the first 5. So I want to make a table of n Fibonacci numbers from n 1 to 5. Okay, so I've got the same list here, 1, 1, 2, 3, 5. Well, let's see what happens if I try to bar chart that table. So you can see here, building Wolfram language code is very easy to do. You start from the inside, you start with Fibonacci, and you build around it. Now I want to make a table of them. Now I want to make a bar chart. Everything is easily readable English. It's very easy to put together. So, cross your fingers. What's going to happen? Okay, get the same output. That's good. Now, what if I check my solution? So, it says I'm correct. One thing it'll say up here, though, is I've generated the correct output, but you used functions we haven't covered yet. This is one of the things we're very proud of. The exercise notebooks, they don't just look at your code. If you're trying to, solve a problem with code, there are an infinite number of ways to do it. Every problem, 2 plus 2, has an infinite number of ways to get the right answer. So you have to be smarter about what it means to be right or wrong code. We've been putting a lot of thought and effort into getting that just right. So this is a great example of you get the right answer. You don't do it exactly like the book has asked, so we can't penalize you, but we want you to know that perhaps you're not using the methods that were covered in that section. So these exercises, they're available for all the sections, all the way down. Sometimes they're not as useful. I mean, a lot of the exercises towards the end will have you create web pages or deploy random melodies and stuff like that. So sometimes having the right answer isn't as helpful, but for most, by and large, most of the exercises, they will be helpful, and they will keep you on the right track as you're trying to learn how to code in the Wolfram language. So with that, these are all the new materials that I wanted to cover. We have a few minutes for Q&A if anyone has any questions they want to cover. And if not, I also had some interest in going over some of the basics of the Wolfram language that make it a good first language. So let me take a second to look through all the questions here in the comments, and we'll see what we have. Okay, so I want to talk about, so we've been trying to get you interested in using the programming lab in your classrooms, trying to get you excited about the fact that it's a real-world professional language. If your students learn it, and it's easy to learn, when they learn it, they can go out and do interesting things with it. So let's talk about how easy it is to do things in the Wolfram language that you can't do in other languages. So I'm going to open up a new notebook here. This is a new slideshow. It's not a one. Okay, good. I always want to check that it knows how to do 1 plus 1. One of the great marks of the Wolfram language is that there are a lot of function names, lots and lots of functions that are built in that will do different things, but they all use a very tight, small amount of syntax. So no matter what function I use, it's almost always going to look like some function, open bracket, argument 1, however many arguments there are, and then close bracket. Almost all functions in the Wolfram language look like that. One of the biggest hurdles I think that people have is that they start with a mathematical notion of using the Wolfram language. Even I did it. I started with 1 plus 1. That doesn't look like this. Well, that's because some things we do so often we give them shorthand. Don't let the shorthand fool you. It's the fastest way to get yourself in trouble. When I send 1 plus 1 to what's called the kernel, he's the guy doing all the computation, what he sees is plus bracket 1 comma 1. And that's what he interprets. So when I type in 1 plus 1, the notebook, the thing I'm typing into, it has to translate it for the kernel. And it tells the kernel, hey, what he means is plus 1 comma 1. And the kernel understands that. Everything that's in the Wolfram language has this structure. And that makes it very easy to debug, very easy to use. So I'm going to go ahead and start with something like creating a list. There are different ways to do it. We've already seen range. So range 10 will give you the first 10 numbers. There are a lot of different ways to create lists, though. I could make a table, something else you've already seen. So table from I over I, let's say 1 to 10. Because Wolfram language is symbolic, these iterators here are totally meaningless. I could make them anything that I want as long as they match. I don't have to worry about, is in this type of iterator, did I use J before, things like that. It's all together. So I could make a list of table here, and another list right in the same line, and they won't interact. This iterator and this iterator do not talk to each other. So that's something that's very handy. It's symbolic. You don't have to worry about keeping track of all those things. Table from, let's go back to I, though. It's a little easier to read. It's distracting. So the table is sort of the basic way to make a list. What if I wanted to make a list, but I wanted to animate through all of the elements of the list? So I wanted to make an animation that, let's say, showed 1, 2, 3, 4, 5, and so on. Well, like I said, the syntax is very tight and very contained. So there are only so many ways that you can have function, bracket, argument, argument. So I'm going to guess that it's called animate, and it is. And I'm just going to animate I from I 1 to 10. So what does that do? And then it animates. It's not exactly the same thing, though, and that's because table, sort of by dint of creating lists, is an integer-based thing. Table assumes that I'm stepping in steps of 1. Animate doesn't need to, though. Animate says, oh, you want to go from 1 to 10? Oh, we can do that however you want. But I can be more explicit and tell it that I want to go from 1 to 10 in steps of 1. There's a lot of fancy machinery going on up here, all these buttons and everything. The Wolfram language just created those. The dynamics are built right in. That's what we mean by an automated language. It would take years to code something like this in C if I had no experience, or Java or anything like that. So I was saying animate, I will use a function called manipulate, which is one of the most useful functions. Yeah, let's do 1 to 10. One of the most useful functions, I think, in the Wolfram language, and it builds dynamic interactive widgets on the fly. And you can do this with any function. I can have anything in here. And so this is just to show you, sort of the different things you can do. They all have a very similar syntax, and they are easy to understand. So let's look through some of these questions here. We have a question here about, is it possible to make presentations with the Wolfram language? That is what our presentations have been in. So you can see this is actually a Wolfram language notebook. I'll show you behind the scenes here. If I get out of full screen, and I will end the slideshow. These are just notebook cells that we put together. There's an easy palette that is built in that I'll show you how to make slideshows in the Wolfram language. And this is something that I know that we're interested in improving soon too. So definitely try to be thinking about presentations in the Wolfram language. I have a question here. What are the recommended hardware, software requirements for students? If you're using it in the cloud, then there aren't that many requirements. If you can get to the, a web page and you can run, most web pages, then you'll be able to run Wolfram language in the cloud. So the Programming Lab, I would say the litmus test is if you can, run a modern web browser and browse the web at reasonable speeds, then you will be in good shape. Let's see here. I have a question. 1, 2, potato, fire truck. How did you invoke fire truck equals 1? That's a little bit of shorthand for table. I can be explicit. I could say my iterator, let's say, call it in this time. The second argument of table, and if I don't know, I can always click into it and hit F1, and it'll bring up the function here. So the second argument is how many copies of expression I want, or if it's a list, then it's taken to be either iterator and then the maximum starting at 1, or I can be more explicit, give it a minimum and a maximum, and give it different steps, so on. So I could do, if I just do in, comma 10, then it knows start at 1, go to 10. If I do, 6, comma 10, it'll go from 6 to 10. If I do 6, comma 10, comma point, 2.3, it'll do it in steps of 0.23. And you have to think about the in cases, but that is how that works. There's a question here about tutorial videos, understanding functions, pure functions, anonymous functions. Videos, I would have to look in, and we can certainly get that answer to you. But as Ayush said, the elementary introduction covers these pretty well. I'll show you the chapter on that. So, oh, come on, pure functions. Pure anonymous functions. I would start here. They're covered very well in this section. And again, you have exercises available that you can try out. So we're down to a few more minutes. I'm going to hand it over to Aish. I think she had some questions that she wanted to answer as well. And then we'll be wrapping up, and we'll continue the Q&A afterwards in a chat Q&A session. But thanks for joining us. I'm going to hand this over to Aish, and we will be in touch with you about the preview program soon.
Hi, there's just one question that I wanted to talk a little bit about. Somebody here asked about, can biology be a theme for the Programming Lab modules and themes that I spent some time talking about? And yes, certainly. What we've seen with the idea behind Programming Lab and the elementary book, like I said, is that this is something that you can use across different curriculum. And with our most recent release of Mathematica 10.3, we've expanded our list of subject areas and functions that can tackle a lot of biology and anatomy related functions, and it's a very impressive addition to what Mathematica can handle. So while I don't have any theme at this moment, I can certainly see biology as a Programming Lab theme, and not just biology. Really, I think with the tech stack that we have, it's really your imagination that is the limit to what sort of engaging material you can create for your students using this technology. It's really limited only by your technical prowess and your imagination as to what can you create. So that's my long answer to that question. And unless somebody else has any more questions here, I'm just checking it out here. I think we should be pretty ready to move over to the chat. I'm just going to give it another minute here.
Well, thanks again, everyone, for joining us. I hope that you've liked all of our new resources, and I hope you're excited about using them in the classroom. If you have any questions, feel free to contact us, and we will be happy to get back to you.
Okay, there's one more interesting question that came up here about teacher notes in the Programming Lab. Yes, but for now that's what Rob mentioned about that being available as a preview material to people who attend this workshop and a few others. So eventually we do hope that they find they will find their way into the Programming Lab and be accessible to everybody.